Welcome everyone. My talk is on the Forgotten Lambda. This is a project that I've been working on for quite a while and it's almost ready. So yeah, it's Serverless Go for Node.js developers. We do most of our development in Node and we thought it'd be really cool to just make sure that we're using the best language for the job. We write a lot of Lambdas and so we're looking at Lambda runtimes. So yeah, my name is Matt. I recently became AWS community builder, so it means I get to do stuff like this, which is really cool, and share things with everyone. So serverless becoming more mainstream. At our company at least, Node.js is the de facto choice for AWS Lambdas. So we generally tend to ask ourselves these questions like, how can we make our Lambdas faster? Would another runtime be better? And how, if we do change, how can we stay agile? How can we keep iterating fast? How can we keep making things to the best of our abilities and keep providing a value for our clients? AWS Lambda, as I'm sure a lot of you know, is a serverless compute service from AWS. It allows developers to manage code, to run code on managed infrastructure in the cloud. Various architectures. We really like ARM64, but you can use x86 if you're from them. And there's OSs. Amazon Linux 2 is the most recent OS, and they support various runtimes. You can code in all your favorite languages. So before we get into this, we ask ourselves, what would the perfect Lambda runtime or Lambda itself? For me, that's a Lambda that's really, really fast. Not just on cold start, but on execution speed. It's going to be fast all the time. We want low latency for your users, memory efficiency as well. So Lambdas get charged on how long they last for and how much memory they use. So we want cheap, and also it's sustainable for the planet if we use less memory. So also we want our Lambdas to be accessible. We want them to be accessible to not just the rest of our team, but also potentially a wider organization. We need readable, simple syntax that anyone can pick up, even if they're not experts in the language. So how do we test that? We're going to test it. Well, first of all, we're going to use a little Lambda speed test. We actually create a Lambda here under real world conditions. So we've got a real world use case. We're going to use CDK as infrastructure as code to deploy, but that's a whole different talk. And we're going to try and use best practice, sensible defaults. So actually using quite a large memory size here, and ARM64, Amazon Linux 2, and we're going to use L2 constructs if they're available for the runtime that we're going to test. So I built something like this. I did this for every single Lambda runtime that we wanted to test. We have a test function, and it adds lists from S3 bucket, and it adds to Dynamo. It's very basic, very simple use case, but one that we actually use quite a lot. We built a little invoker function so we can invoke it remotely, but we don't have to manually invoke the test function, each of them all at the same time. But first, let's get a baseline. Node.js is our de facto choice. Let's talk about Node. In my opinion, dynamic languages are the best for fast development, really quick, really easy to work with. And JavaScript is the best dynamic language. Other people will say Python. I really like JavaScript. SDK is very well optimized for AWS. And with Node.js on the back end, we can have language consistency across a whole project from front end to back end. Front end JavaScript framework or TypeScript framework, back end TypeScript. And we use types, so it's a bit more safety. But for fast execution, potentially, I think we can do better. So let's get a baseline. Let's look at our cold start times. Right. So we tested here Python, Node 18, Node 16. Node 16 with a V2 SDK, which comes bundled. Node 18 with a V3 SDK, which comes bundled with the Lambda runtime. And we see some quite interesting results here. Node 18, despite being bigger, is actually faster as a runtime with our little test that we established. So Node 16 does seem slow. So just this one line of change, well, one line turned to two lines, where we import our clients separately. I actually just wrote bad code, so then I changed it to the second one. And we got a 17% faster SDK, or 17% faster Lambda run. And that's really, really significant, but still Node 16 is not as fast as Node 18 or Python. Okay, but do we actually care about cold starts? And what does this mean for other Lambda runtimes? Well, we might not care so much about cold starts in general, but it might not be that useful for our application. You only cold start a Lambda if you wait 15 after it's being last invoked, and then you have to reload all of your memory back into the micro VM. So we did a little load test. It's really straightforward. You just used a load test from npm. We gave our Lambda a URL and hit it with 1,000 requests, maximum 5 concurrency, 10 requests a second. Really wanted to do more, but I kind of ran out of AWS credits. So we're going to do some load testing. Node 16, Node 18 Python, we're still just using like our basic Lambdas. And we see that Node 60 has a big variation from mean latency to 95 percentile to 99 percentile. We have a big difference. Node 18, they've done a lot of work with the SDK. You can see that from here. It's a much bigger package, yet still they've managed to keep latency very, very slow and consistent across all, like, many runs. Python is so-so. But can we do better? Well, maybe. I just wanted to give a shout out here to Maxime David's GitHub repo. He did a lot of Lambda performance testing, only with Hello World Lambdas, but he's done loads and loads and loads of different Lambda runtimes, and more people are adding them more people are adding to them every day. So if you want to check out his repo, it's pretty cool. Add your favorite runtime. He loves Rust. So I know a lot of people love Rust, but Maxime David really loves Rust. And he's such a big advocate. A very small bundle size. He's managed to measure some crazy, super fast cold start times, like sub 20 milliseconds almost, which is like crazy fast. There's a Cargo Lambda tool from AWS Labs, which is used to build Rust for AL2. But for us, it's like Rust has got a few big deal breakers. There's no level 2 CDK support, which is like a bit of an issue. But most importantly, the AWS SDK is still in developer preview. So like we don't really want to use it on production projects. And it's very difficult for new developers. If we've got a whole project in TypeScript and we're wanting to jump into like 1 or 2 Lambdas in Rust, we're really going to struggle. It's going to have a lot of time training and we're going to lose agility. So Java, why don't we write them in Java? Java 11 now supports snap start. You don't need to load the JVM for some invocations. Instead, AWS restores the execution environment from a snapshot if it's available. Strongly typed, huge ecosystem. It's been around for ages. Again, I have a couple of problems with Java. If you love it, it works. But starting from nothing, there's loads to learn. And again, if we're just doing it once or twice, like we want to use Node really. If we want to do it once or twice, it's going to be really bulky for like irregular use. So there's some other options. Ruby, it's interpreted. Like, it'd be really cool if I had a compiled language that compiled really small. And .NET, I've seen some horrendous runtime, like cold start times to .NET, so I wasn't that interested to jump in. So it kind of leaves one option, and that's Go. So Go was developed in 2007 by some engineers at Google. It was released open source in 2009, and it's focused on simplicity and developer productivity. Wonderful words if you're thinking about agile development. And you can see that this is a Google Trends graph, where we see like it had a massive peak in sort of end of 2019, where a lot of startups were using it, but also big enterprise. There's some case studies from Microsoft, obviously a lot from Google, there's some from Twitch. And it's like, it was being used in a lot of places. So we had a big dip over the pandemic, and now it's actually still at a peak. People love Go, they're just not serverless. So why do we like Go? It's easy to learn syntax, readability, usability like Python or JavaScript. I'll show you some in a bit, but it's super straightforward to look at. It's compiled, small static binary, no dependencies. Static typing, garbage collection and runtime, these are all words we like to hear when we're looking at serverless. High performance networking, multiprocessing, not as useful, but having native concurrency is quite interesting. When there's 2 things you want to do at the same time, potentially, you've already provisioned quite a large Lambda memory size, and you're like, could do them at the same time. So it can really, really speed up cold start times, especially for like instantiating clients for the SDK. Anyway, we'll have a look. So CDK support is still in alpha, but it's a very, very good package. I'd be pretty happy to use it. And unit testing is built into Go. It's a very simple package management, comprehensive standard library, all stuff we like to see. So let's test some cold start times. Cold start times for Go is compiled. So we can see that's already like small package size. It's already lending to it. It's at 500 milliseconds in this test for execution time for cold start performance. So obviously a lot faster than even like Node 18. But like Go has native concurrency, and our test was doing 2 things at once. Well, almost 2 things at once. We're instantiating 2 clients. So why don't we do them both at the same time? Well, in Go is really straightforward to do concurrency. We have Go routines. So you create a wait group, you add one to it, anonymous function, you stick some stuff in that, and suddenly that's split off and done on another thread. And then you just wait for it at the end. It's really, really straightforward. Like you add those 5, 6 lines of code and you're done. And so how did that help? Well, as you can see from the thing on the left, helped quite a lot. we're down to sort of 350 milliseconds of a cold start time, which is way faster. Considering Node 16, which we normally use like quite a lot, is at like 1750 milliseconds. Like, we're like so much faster, so much faster. So yeah, Go potentially really good option for cold start times. But we talked before, and it's like, at this point, we really have to take a step back and think about what we're trying to achieve here. So do we really need Go? Do we have time to learn features? Go routines might be very simple, but some of the complex elements of Go are indeed, they are just complex. Is Go actually going to improve the product just for having it like in a couple of lambdas? Are we rewriting all our lambdas? So we go back to load testing, and we see that Go is actually not looking that great. It's the green box on the right-hand side. It's actually slower than all the others when we load test the lambdas. So this really shows how much AWS work on the Node SDK. So latency in Go is just much slower. It's obviously not the package, because we've just seen that was pretty quick. It's actually just the latency of the SDK calls. It's making it much slower. So should we switch from Node to Go? Well, from the load test results, probably not. Like, let's be honest, that wasn't great. But like, let's not end this here. If we had like quite a lot of memory when we were doing those tests initially. We had like 1,024 megabytes of memory, which for a Lambda is actually quite a lot. Normally we'd run on like 518, I think is the number, or something around there, or even smaller. So if you go to the default memory size, 128 megabytes. So for those that you don't know, Lambda memory size is actually proportional to compute speed. So lowering the memory, we actually lower the compute speed. And you can see that Go, when we lower the memory, is actually like the best Lambda option. So if we want a cheap Lambda, well, potentially a cheap Lambda, if we want like less memory hogging Lambda, then Go could be quite useful. And also, like, there is one massive benefit of compiled languages. Like, your max memory usage is so much lower. So because you're using less memory, like initially, we're actually using less energy, and it's much better for the planet. So we probably don't want to switch in most cases. But like, we tried. So I came up with like a few little rules. So we should use Go when we absolutely need fast cold starts. Like these things that are like mission critical to when they get called, they need to run quickly. And like, they're running really quickly, like 300 milliseconds is not a shabby latency for a Lambda function that's doing two things. I know Mo's like smiling at me because this is probably like 1 millisecond or something. But we'll get to that in a bit. So if you want low memory, low cost functions, Go uses 30% less memory than the equivalent Python or Node function, more than 30% if you're talking about Node. And it can make use of concurrency. If you've got like applications where you can make use of that concurrency, it's awesome. And last thing, if you have time to make the best use of these features, Go's got some awesome stuff, but you really have to dig into it to make the most use of it. Even though it's built as a simple language, the syntax might be simple, your mate next to you might understand it, but if you can't implement it properly, then you're just writing bad code. So drive change with a business case, not a technical angle, unfortunately. So in conclusion, Node 18 runtime is pretty good in most situations. That's basically what we've established here. I know it was a talk about Go, but everyone used Node 18. It's awesome. We should 100% be using the V3 JavaScript SDK by default. Anyone who's still back on the V2, like, get out of that. Go should be considered like really well for anything that's cold start critical, or you want low memory usage. And Go is 30%, more than 30% sustainable than Node or Python with memory usage. So in terms of like future work, for me, this is like project. So I'd like to continue on really. Want to make some fast. One thing that'd be quite useful, I think, would be automated tree shaking with Node. Something that we haven't really covered that much, but if we want to reduce package size on our deployed Lambdas, something that we can run on deployment, maybe as a custom resource in CDK, in our infrastructure as code, could be really, really cool. Also, guys, if you haven't heard about Bun, Bun is another TypeScript runtime like Node. Well, it actually runs TypeScript natively, which is pretty cool. So being able to use that with my Lambdas would be quite interesting. Never done that, so I'd like to jump onto that. Also, improve my Go code. There's probably loads of optimizations that could be made. Just need to get better. And try with Rust and Java. This is what I've been pushing back on for quite a long time, but I probably should try. Newer Lambda runtimes. This is kind of a request for the AWS team, really. I'd really like to get some newer Lambda runtimes yeah, like get it supported. Python 3.11 is like been out for ages now. That'd be really cool if that was supported. And if it can't be supported, a way to upload my own runtime image on the back end. Basically, all Lambda does is it loads an image, an IMI image, into a micro VM and starts it up. So if I could upload my own image, that would be great as well. So yeah, that's my own little request for AWS Lambda.
Awesome talk. Thanks for that. I feel like I learned a lot. Just wondering, with the CDK for Go being an alpha, how much of that can change? And so, like, with that in mind, would production applications using it be safe if there's any breaking changes in the API?
With CDK, there's always breaking changes. It's like still not incredibly stable. They love breaking changes. So I would fix your version of CDK. The alpha package will never go beyond a certain point, so they'll just incorporate into the main package when it actually needs to be released. So your alpha package probably isn't going to change that much. It already works really well. So when you run Go in CDK, you just attach an entry directory. As long as that's got a go.mod file, which is the equivalent to your package.json, it will compile the Go on deployment. Go compiles really, really fast. It compiles with your own version of Go that's installed, if you have it installed. If you don't have it installed, it uses Docker, but if you've got a Mac, never use Docker because like it's really slow. So yeah.
Really good talk. So if you were starting from scratch and you were not tied to Node, would you use Go as the default language for building Lambdas for a new project? Like knowing the advantages?
I would always start a project with my infrastructure, and I'm going to start infrastructure in CDK because I really like CDK. It allows us to write infrastructure as code in TypeScript. So we can also write it in Go, incidentally. You can write your CDK infrastructure in pretty much any language, but the TypeScript support is better. There's more tutorials on it. There's more, like, people are doing it a lot more. So I'm not a Go expert. So I would pick TypeScript to write my CDK. And if I had a critical Lambda, it's very easy to write it in Go.
Thank you very much for the talk. That was great. My question is, how did you measure those performance numbers that you had on the screens? And secondly, you mentioned that you were doing about 10 requests a second and a total of 1,000 requests. Is that enough to actually be able to get a benchmark that is meaningful?
Yeah, great question. So load testing, we actually just ran it. I ran with this package. I gave each Lambda a URL, so just an open URL, and I just pinged the URL 1,000 times with this package, load test package, and it returns, like, I knew my Lambdas were working, so the response it returns hopefully was right. And yeah, it measures like latency in the response. So this package is really good. Someone tried to make one specifically for Lambdas and it failed about 7 years ago. It's disgusting. Tried that, didn't work. But this package is really good. In terms of like cold start testing, I ran it every 16 minutes for a whole day and just took an average. That was today, by the way. Yeah. So yeah, 1,000 requests might not be overly meaningful, especially if you're doing like huge stuff, but I think you can be fairly confident in compiled languages. I think you'd more struggle to justify this with the Python tests or something like that.
Thank you for the talk. It's interesting that you found that on lower memory size, Go was more performant. Have you tried building a histogram to see when it changes?
No, I haven't. It's definitely one for future. There's a few things I want to check about memory size as well. A lot of people have done like the same Lambda and they've iterated through memory sizes and they've worked out like which is going to be cheaper. It's actually a tool that does that for you. I'm pretty sure Lumigo does that for you. Lambda Power Tuner also does that for you. So yeah, like that is worth doing for 6 different Lambdas that I ended up having here after I had all the concurrency ones and like the tree shaken ones. That wasn't like something that I was like really focused on, but potentially could be useful for the future. One thing I actually wanted to check more was on what this different, like how much this difference is actually related to SDK latency. This is something I didn't time. So in my Lambda, I could actually time how long it takes for the SDK to come back. And that would be something that I'd be more interested in, because if you look at the scales on the left here and the right, they're actually 10 times each other. So on the left, the latency matters way less than it does on the right. So the right, I think, is latency driven and the left is language driven. If there are no more questions, thank you very much. And thank you guys.